Welcome. Today we're going to be doing continuing logarithms, and we're going to start with graphing logarithmic equations, and then we'll move into the properties of logarithms. So the first thing we've got here is we're going to be graphing y equals log base 4 of x. I strongly suggest that when you work with a problem like this, you rewrite it in a form that's easier for you to graph. As I said before, I don't think in logs very well. So I'm going to rewrite this in exponential form. This would be 4 to the y equals x. So in this problem, we're going to plug values in for y because it's a lot easier to find out the result if I plug y in here than it is to plug a value in here and work backward. So the first thing I notice is that if I put the fraction if I put 0 in, and put that in the middle, 4 to the 0 is 1. If I put 1 in, 4 to the 1 is 4. It's already thinking of the next one. If I put 2 in, I get 16. Now, I could put 1/2 in because we know 1/2 is the square root, and 4 happens to be a nice number that square roots. It gives me 2. It's not necessary to do that, but I thought I'd throw that in. What is necessary is you need at least a couple negative values. So 4 to the negative 1 is 1 over 4 to the positive 1, so 1/4. 4 to the negative 2 is 1 over 4 to the positive 2, or 1/16. So this is very reminiscent of what we did a couple weeks ago when we were graphing exponential functions. Well, logarithmic functions are very similar. All right, so I'm going to plot these points, and let's see. I've got 1. Remember, now that we have plugged in for y, gotten answers out for x, when we go to graph it, I'm going to go 1, 0, not 0, 1. 1, 0. Let's see, 4. 1, 2, 3, 4, 1. 16, 2, so that's way out here somewhere. 2, 1/2. All right. 1/4, negative 1. 1/16, negative 2. Can you see it's getting close to x being 0? Not y being 0. So this is going to stay along here and then swoop out. All right. Now it didn't actually cross there, but my hand just moved. All right. So remember before we had an asymptote? Well, now it's a vertical asymptote here. Now, let's see what happens when we plug in x plus 3. It's almost the same thing, right? The only difference between these two is instead of x, it's x plus 3 in parentheses. That's important, because if it were just x and then plus 3 without the parentheses, that means log base 4 of x and then plus 3. But with the parentheses, it's log base 4 of x plus 3. Okay, see the difference in those two? All right, I'm going to rewrite this. That's going to take a minute, and it's important to see the change in the rewriting. 4 to the y equals x plus 3. We want x by itself, so I'm going to subtract 3. So this is 4 to the y, and then minus the number 3, not an exponent, equals x. All right, let's plug in some values here. So if I put 0 in again, So 4 to the 0 is 1, minus 3 is negative 2. If I put 1, 4 to the 1 is 4, minus 3 is 1. 2, 4 to the second minus 3, 16 minus 3 is 13. But again, we're plugging in for y, getting answers out for x. Negative 1. 1/4 minus 3 is negative 2 and 3/4. Not negative 2 and 1/4. You're taking 1/4 away from negative 3 and making it, because it's a positive 1/4. So 3 minus 1/4 is 2 and 1/4, 2 and 3/4, and it's negative. If I put negative 2, that means I'm saying 1/16 minus 3, or negative 3 plus 1/16. That's negative 2 and 15 over 16. It's very, very close to negative 3. All right, let's plot these points. So negative 2, 0, 1, 1, 13, 2, so it's somewhere out here. That's not a very good drawing. It's actually probably below that, but you would see that if you looked on Desmos. Let's see, what other ones? Negative 2 and 3/4, negative 2 and 3/4, negative 1, negative 2 and 15/16, negative 2. So my line comes along and then arcs out. It doesn't actually cross that. The red line is actually a little bit below this green line in a proper drawing. I'm a little off. And my asymptote is at, let me change the color of that, it's hard to see that. There we go. My asymptote is at x equals negative 3. It's not going to cross negative 3 towards the left. All right, let's continue. That's enough graphing. Properties of logarithms. B, m, and n are positive numbers such that b is not equal to 1. If that's all true, then the product property log base b of m times n is the same as separate logs where the two results are added. So multiplying of inside the log separates into separate logs added. So multiplication becomes addition. You'll notice the connection between exponents and logs, that when you are multiplying bases, you add their exponents. When you are dividing, you change it to separate logs subtracted. And when you raise to the power, you multiply outside the log. So the exponent becomes the multiplier, or almost like a coefficient of the log. It's not a coefficient, but like one. So the multiplier becomes the exponent becomes the multiplier. Let's see how this works out. We're going to take the original and expand it out. Now, why do this? Some people would ask, this makes no sense. Why are we spending time doing this? It's so that you can later learn to manipulate logarithms. We've manipulated other things like equations to get it in the form we like, or something that will simplify. Well, we're going to do that with logarithms, and eventually you get to the point where you're actually utilizing that. So, division is the main thing that's happening in this problem. So I'm going to break this into log base 3 of 2x minus log base 3 of 11. Then this is multiplied, so I have to break that apart. Log base 3 of 2 plus log base 3 of x minus log base 3 of 11. And there's your answer here. All right. As I go through these, if you discover you feel like, I know how to do this, pause it and before I start the problem, and then do it on your own and see how well you did. This one, multiplying is happening between the coefficient and the variable to a power. So that's how we're going to start, by breaking log base 4 of 7 plus log base 4 of x to the 4th. Now I've got a variable to a power, so I'm going to break that apart. Log base 4 of 7 plus, the power becomes the multiplier, 4 times log base 4 of x. And there you have it. That's expanded. All right. Let's take a look down here. This is just multiply. Log base 5, this is common log, right? So log base 10 of 5 plus log of x. So if it does not have a base, you don't have to write the base because it's assumed to be base 10. Now, as I said before, if you've tried it on your own, hopefully you have by this point, give this one a try, see if you can do it. It's a little bit tricky, and there's one little thing that you may have not picked up on. All right, here we go. Log base 7 of y to the 3rd minus log base 7 of 20x to the 5th. Now, one of the things I've seen people do often is they think at this point they can pull the 5 out to the front. No. The 5 is the exponent just for the x, not for the 20, so you can't do that yet. All right, so I'm going to bring this out front. That's done. That part, can't do any more with. This minus is applying to this whole thing. It's very tricky. So minus parentheses. Now I'm going to break this apart. Log base 7, 20 plus log base 7 x to the 5th. Now you could have applied this negative to both parts if you wanted, instead of having the parenthesis, but either the minus with the plus here or applying it to both parts is necessary. Otherwise, it's not going to be accurate. 3 log base 7y minus log base 720 parentheses plus 5, bring the power out, log base 7x. There's your final expansion. So this was expanding logs. Now we're going to talk condensing logs. It's the reverse of expanding. I have subtraction. When I put them together, it's division. So this is log base 5 of 2 divided by 3. I'm going to do this one next, the power. And as I said before, if you think you get it, try it on your own and see how I do it after you've paused it. The multiplier becomes the exponent. So log base 4 of y to the 6 plus log base 4 of x to the 8. Then I have to change add to multiply log base 4 of, it doesn't matter which ones comes first, I'll just put it in the order they wrote it, y to the 6, x to the 8, or you could have said x to the 8, y to the 6, same thing. Let's give this one a try. Multiplier becomes the power, so log base 7 of x to the third minus log base 7 of 2. And then the subtraction becomes division. Log base 7 of x to the third over 2. There's your answer here. Right here. Okay. Now, this one. That's an 11 log. So, log of v to the 11 plus log of k to the 5th minus log of z to the 3rd. Now, technically, you could say plus negative 3 power, but I wouldn't do it that way. Addition becomes multiplying, and subtraction is division. So I'm going to do this all in one. Log of v to the 11, k to the 5 over, excuse me, over z to the 3rd. And there is your final answer. Now I could have done this together first and then separately put it on the bottom, but all in one, I'm multiplying these two and dividing by this one. All right, now there are a few problems in the homework where they give you this information and they ask you to use that to approximate the value of this. So they're saying we know the value of log base 5 of 4 is approximately 0.861, and log base 5 of 9 is approximately 1.365. Use that information to do this one. Well, can you think of something that you can do with either 4 or 9 to get 81? Well, some of you would have said, oops, that's not what I meant. Some of you would have said that 81 is 9 to the 2nd. Okay, so log base 5 of 9 to the 2nd, I can rewrite that as 2 times log base 5 of 9. And that means 2 times 1.365. And when you get that answer, let's see, 2 times 5 is 10, 0, 1, 13, 7, 2. 2.730. Now the other way you could think of it as log base 5 of 9 times 9. That's another way of writing 9 squared, right? Well, 9 times 9, so that is log base 5 of 9 plus log base 5 of 9. And since that's the case, that's 1.365 plus 1.365, which is 2.73. And that is the whole thing. So sometimes it's working with 4 and 9, sometimes it's just 4, sometimes it's just 9 like this one, and that's how you're going to manipulate it. And I'm just going to make sure that I didn't make a calculation error. I'm pretty sure I did it correctly, but it's always good to check. Let's see. Yeah, I have it right. I just want to be doubly sure. So you have your homework, and that's everything. Have a great day.